All right, welcome. Okay, so I want to look at standard error of mean very quickly. And I use ChatGPT because it draws beautifully and gives beautiful formulas. So when you take a sample, obviously your level of accuracy is not going to be 100%. So you want to be able to map on what you predict the standard expected amount of error is, which is going to be a range or an approximation, okay? And that approximation is going to help you determine, okay, how accurate are my numbers? And also, is this sample going to accurately represent what's actually going on in the population? So say you're measuring the height of students in a college and you take 5 samples. So for each sample, you can determine a different standard error of mean depending on the size of the sample. So for each sample, you'll get a different standard deviation, right? Represented here by sigma, which is how much standardly you would expect a deviation from the mean in the population. Let me show you what that is here. Okay, so say our college students' average height in the entire population is 170 centimeters. Our standard deviations are within 10 centimeters of the mean, okay? And approximately 68% of all students are going to fall into this area. In the measurement of standard deviation, one standard deviation is approximately 68% of students are going to be within 10 centimeters of the mean. But now, how big is this area of error going to be for our sample? That's what we're calculating. We're calculating this line here to say, oh, look. Our sample is most likely within 2 centimeters of the true standard, the true average for the population. That's what we're calculating. Okay, and what we're doing, so we take our standard deviation there, which in this case will be 10 centimeters, dividing it by the square root of the number of individual observations in the sample. So if we take a sample of 10 students, that n will be 10. If we take a sample of 24 students, that n will be 24. The larger the sample, the smaller the standard error of the mean, okay? And the closer that green line will be to the average. The smaller the population, the more likely it is that our mean for the sample is going to be off and far away from the true mean. Okay. All right. And that is the video. I hope that helps.